Steel is iron that has most of its impurities removed with a consistent concentration of carbon throughout. There probably doesn't go a day without you seeing steel in everyday life. It's used in washing machines, stainless steel appliances, aesthetics for appliances, weapons, machines, bridges, etc. It has so many different purposes due to its high performance and reasonable price. Steel has different methods of production. One is through an open hearth furnace where steel is created from pig iron, limestone, and iron ore going into an open hearth furnace and is heated to about 1600 degrees Fahrenheit. Impurities are oxidized through this method and float into slag that floats on the surface. Another method of production is through the Bessemer process, where impurities are oxidized by blowing air through the molten iron in a Bessemer converter, and impurities unite with oxygen to form oxides. There is also the basic oxygen furnace, which main advantage is its speed. This is when high purity oxygen blows through pig iron, and in turn carbon, silicon, manganese, phosphorus are lowered. Chemical cleaning agents called fluxes are added, which help reduce levels of sulfur and phosphorus. These are some examples of the steel production process. Steel has many benefits in society. In particular, steel helps create durable products, generates employment, reduces emissions, and helps conserve raw materials for sustainability. It also helps the economy through generating substantial export earnings and tax revenues. In 2016, the world crude steel production had reached 1,630 million tons, with China accounting for 45% of the global market for steel. One of the most important and interesting characteristics of steel is that it is 100% recyclable, with no downgrading in quality when recycled. With the use of steel, we can look forward to a more sustainable future.
Swords have been in use for as long as humanity has performed metalworking. With the advent of the Iron Age a few thousand years ago, swords became ubiquitous with contemporary infantry and cavalry formations. The composition of the sword has changed over time, starting first as bronze and then transitioning to iron. From there it transitioned to various forms of steel. The varieties of steel used for sword production depended both on the time of production as well as what someone was willing to pay for their sword. During the Iron Age, steel was extremely expensive and required special labor and training to produce. Hence, most swords were composed of iron during this time period. The iron itself was work hardened by hammering, making it so that the iron could both hold an edge and bend under stress without snapping. Following this, steel became more ubiquitous in the Middle Ages. Steel would be hardened into an austenite crystalline configuration and then tempered to martensite. This transition is still followed by bladesmiths and industrial production to this day for most high carbon or tool steel blades. Swords can be classified based on their shape, the cutting edges, one or two, and their overall length and profile, as well as whether they are one-handed, bastard, or two-handed. A bastard sword can be efficiently used as a one- or two-handed weapon. There's a very good reason that steel is still used for most blades. All other metals and alloys are poor replacements. Titanium is too flexible, light, and expensive to employ in most blades outside of rapiers and lances. Uranium is too radioactive and brittle, its only military applications being used as kinetic weapons due to density or nuclear power or weapons. With that said, newer alloys of steel are constantly being developed, each with their own benefits and losses. Historically, Damascus and Wootz steel, the former of which is lost to history, were unique varieties of steel produced in India. They have been found to have carbon nanotubes and a unique alloy composition due to elemental impurities in the iron ore where the iron was mined. Metallurgists have nearly gotten this molybdenum and vanadium concentrations to be correct to properly imitate these ancient steels, but so far only Wootz has been properly resurrected in the 20th and 21st centuries.